Since 2011, the Russian energy corporation Gazprom and a group of large investors have been working on one of the longest and highest capacity offshore gas pipelines in the world. The Nord Stream 2 is a pair of large diameter natural gas pipelines running along the bottom of the Baltic Sea from the Russian coast near St. Petersburg to the northern coast of Germany near Greifswald. Planning, design, and construction of Nord Stream 2 was mired in political controversy, not only because of climate-related apprehensions over new fossil fuel infrastructure, but also over concerns that the pipeline could be used as a geopolitical weapon by Russia against other European countries. Still, construction began in 2016 and finished 5 years later at the end of 2021. As the German government worked towards certifying the pipeline to begin operation, Russia launched a military invasion of Ukraine. This unjustified and unconscionable attack on a sovereign nation has received widespread international condemnation, followed up with a litany of sanctions on Russia and its most senior leaders. Part of the response included Germany halting the certification of this divisive $10 billion mega project. As of this video's production, the invasion of Ukraine is ongoing, and future international relations between Russia and most of the developed world are unlikely to improve anytime soon. The U.S. put sanctions on the company in charge of the pipeline and its senior officers. The project's website has been taken offline, and most of the employees have been fired or quit. These circumstances raise plenty of questions. How do you install a pipeline at the bottom of the Baltic Sea? Why is this line so important to geopolitics? And what does the future hold for what may be the world's most controversial infrastructure project? I'm Grady, and this is Practical Engineering. In today's episode, we're talking about the Nord Stream 2 pipeline. Like its predecessor, Nord Stream, the goal of the Nord Stream 2 pipeline is to provide a direct connection between the vast reserves of natural gas in Russia and the energy-hungry markets of Europe. With a length of 1,230 kilometers, or 764 miles each, the twin pipes pass through the territorial waters, or economic exclusion zones, of 5 countries, the 2 landfall nations of Russia and Germany, as well as Finland, Sweden, and Denmark. Also like its predecessor, the Nord Stream 2 is owned by a subsidiary of Gazprom, a Russian state-owned enterprise and one of the largest companies in the world, and financed by a coterie of other international oil and gas firms. The project has a long, complex, and controversial history. This video is meant to highlight the engineering details of the project, but in this case, the politics can't be ignored. I'll do my best to hit the high points, but check out some of the more comprehensive journalism on the subject before you form any strong opinions. Even before construction began, Nord Stream 2 had some massive obstacles to overcome. The Baltic is one of the world's most polluted seas, and all the countries around it have a vested interest in making sure those conditions don't worsen. Pipeline construction can create harmful levels of underwater noise, affect fisheries, disrupt water quality, and even impact the cultural heritage of shipwrecks along the seafloor. Each country along the route imposed strict environmental requirements before construction permits would be issued. The planning phase for the pipeline involved detailed underwater surveys of the seabed to help choose the most feasible route along the way. This survey also helped identify unexploded ordnances from World Wars I and II. Where possible, the pipeline was routed around these munitions, but in some cases, they had to be detonated in place. When this was done, the contractors used bubble curtains around each explosion to mitigate the noise impacts on marine life. The logistics of producing so much pipe was also a huge challenge. The pipe sections used for the Nord Stream 2 were about 1,150 millimeters, or 45 inches in diameter, and 12 meters, or 40 feet long. They started out as steel plates that were rolled into pipe sections, welded, stretched, beveled, and inspected for quality. An interior epoxy anti-friction coating was applied to minimize the pressure losses in the extremely long line. Then an exterior coating was applied to protect against corrosion in the harsh saltwater environment. And the entire project required manufacture of more than 200,000 of these pipe sections. That's an average production rate of nearly 100 pipe sections per day, spread between 3 suppliers. Each pipe section was transported by rail to a port in Finland or Germany to receive another exterior coating, this time of concrete. This concrete weight coating was applied to increase the pipeline's stability on the seabed. Doubling the weight of each pipe from 12 to 24 metric tons, the concrete would help resist the buoyancy and underwater currents that can move the line over time. It also provided mechanical protection during handling, transport, pipe lay, and for long-term exposure along the seabed. After weight coating, the pipes were shipped to storage yards along the coast, where they would eventually be transported by ship to large pipe lay vessels working in the Baltic Sea. These pipe lay vessels were floating factories employing hundreds of workers each, and the Nord Stream 2 project had up to 5 working simultaneously. On the largest vessels, the basic process for pipe laying was first to weld 2 pipe sections together to create what's called a double joint. These welds got a detailed inspection, and if they passed, the double joint moved to a central assembly line to be connected to the main pipe string. There you got more welding and inspection. If everything checked out, a heat shrink sleeve was placed around each weld, and then polyurethane foam poured into a mold between the concrete coatings to further protect against corrosion while allowing the pipe string to flex during placement. Once complete, the vessel could advance a little further along the route while lowering the pipeline into its final position. This was a 24/7 operation, and some of these pipe lay vessels could complete 3 kilometers in a day. In many locations, they could just lay pipe directly on the seabed. It was smooth enough to keep the line from deflecting too much and soft enough to avoid damage to the pipes. However, that wasn't the case along the entire route. In some shallow waters where the pipelines were exposed to hydrodynamic forces like waves and currents, the lines were placed in excavated trenches and backfilled. There were also many areas along the route that were rugged enough to create free spans of unsupported pipeline. Fall pipe vessels were deployed ahead of the pipe installation to fill depressions with rock and gravel to provide a smoother path along the seabed for the line. Finally, at locations where the Nord Stream 2 lines would cross other subsea cables or pipes like power, telecommunications cables, and other pipelines, rock mattresses were installed to protect each utility at the intersection. Each end of the pipeline came with a tremendous amount of infrastructure as well. At the German landfall, the pipe was tunneled onshore to the receiving station. This facility includes shutdown valves, filters, preheaters, and pressure reduction equipment to allow gas to be delivered into the European natural gas grid. Both facilities also included equipment for pipeline inspection gauges, also known as PIGs. These devices are launched from Russia into each pipeline, pushed along by the gas pressure for the entire 1,200-kilometer journey. The PIGs scan for problems like corrosion or mechanical damage and collect data that can be downloaded when they reach the end of the line in Germany. Installing multiple sections of pipe simultaneously sped up construction of the line, but it created a serious challenge as well. How do you connect segments of pipe that have already been installed along the seabed? That's the job of maybe the most impressive operation of the entire project, the Above Water Tie-In, or AWTI. The separate sections of pipeline were carefully installed on the seabed so their ends overlapped. When it came time to tie them together, first divers installed buoyancy tanks to each end to make them easier to lift. Then davit cranes along the side of the tie-in vessel attached to each pipe and lifted their ends above the waterline. These ends didn't have a concrete weight coating to make them lighter and able to be cut to the exact length needed. The pipes were cut and beveled, welded, tested, and coated for corrosion protection. Finally, the tie-in vessel could lay the complete pipe back down on the seafloor, forming a small horizontal arc off the main alignment where divers remove the buoyancy tanks and detach the cranes. The Nord Stream 2 required several above-water tie-ins during construction. It seems simple enough, but each one took about 3 weeks to complete. The final AWTI was completed in September 2021, marking the end of construction of the Nord Stream 2. Although Europe's in the midst of a major transition away from fossil fuels to renewable sources, the demand for natural gas is still high and expected to remain that way for the foreseeable future. In addition, Germany is planning to shutter the last 3 of its nuclear plants by the end of 2022, using natural gas as a bridge toward the expansion of wind and solar. With gas demands remaining consistently high, many fear that the Nord Stream and Nord Stream 2 pipelines put Russia in a position to exert political influence over its European neighbors. Nord Stream 2 would also allow more Russian gas to bypass Ukraine, depriving it of the transit fees it gets from gas lines through its borders. As early as 2016, politicians in various countries around the world were coming out in opposition to the project. The US played a large role in trying to delay or stop Nord Stream 2 altogether, with sanctions on the ships involved in construction, plus a host of Russian companies, while carefully avoiding serious impacts to the contractors of its German ally. US President Biden waived those sanctions in mid-2021 in a bid to improve US-German relations, but the Russian invasion of Ukraine changed everything. The US immediately reimposed the sanctions, and Germany froze certification of the project. The Nord Stream 2 company has been mostly silent so far, but there aren't many good outcomes of spending $10 billion on design and construction of a pipeline that can't be used. Most news sources appear to agree that they are completely insolvent and have fired all their employees. In addition, most of the non-Russian companies involved in the project have already written off their investments and walked away. This simple pipeline highlights the tremendous complexity of infrastructure and geopolitics. It can be extremely difficult for a normal citizen to know what they stand to gain or lose from a project like this. We want cheap energy, we want warm homes during the winter, but we don't want the global climate to change, and we definitely don't want an unpredictable and misguided authoritarian leader to hold a major portion of Europe's gas supplies hostage for political gains. In some ways, Putin's invasion of Ukraine simplified these complex issues because it gave Germany and the US no choice but to kill the project. There's a lot of uncertainty right now with how the conflict will end and what the world will look like when the dust settles, but it seems doubtful now that the Nord Stream 2, this incredible achievement of engineering, logistics, and maritime construction, will ever be anything more than an empty tube of concrete and steel at the bottom of the Baltic Sea. And maybe that's for the best. Thank you for watching, and let me know what you think.